This video is a follow-up to LIMS Nucleus installation on Amazon Web Services EC2 instance. In that video, we used a single bash script to install LIMS Nucleus. That bash script performed these functions. It is running on a Debian instance, so the first step is to apt-get install some required software: security, Git, the naming service, and the Postgres client. Next, the Guix package manager is installed, followed by the application, and then the PostgreSQL database, including loading all the tables, stored procedures, and example data. It is this functionality right here that I would like to repackage into a Guix module and then load into the Guix store. Why do that? Well, I'd like to take advantage of some of the features of the Guix package manager. First is flexibility. Currently, the installation is a single script that installs a local PostgreSQL database. That is convenient, makes for easy configuration, but it puts the burden of backup, restore, repair on the end user. Many customers would like to outsource that to either a cloud provider or to their internal IT department. So I would like to provide the flexibility to provide connection parameters so that a remote database can be set up. Next, I'd like to take advantage of the Guix packaging mechanism for distribution, installation, and upgrade of the application. I'd like to turn my code into a dependency. Ultimately, I would like a single command installation: Guix package install LIMS Nucleus. But that requires that all of my dependencies be packaged and in the store. The pack command is a convenient way to distribute software to non-Guix users, but it requires that all the modules be present in the store. And lastly, I'd like to take advantage of the reproducibility that the Guix package manager offers. My archive will be assigned a hash code. That hash code is a signature for all of the files within the archive. If any file changes, the hash changes, and that hash is registered with each generation. Here is the PostgreSQL code from the bash script that installs the database. It starts by making a data directory, modifying some environment variables, initializing the data directory, which copies multiple files into that directory, some being configuration files. I overwrite the supplied configuration files with my own custom configuration files, start up the database, and then run a series of SQL scripts that create users, tables, install the storage procedures, and example data. I will not get into the details of setting up a Postgres database. Suffice it to say, this is the code that needs to be repackaged into a Guix scheme program for ultimate packaging by Guix. We will do that using Guix Hall. Hall is code that writes code. You can read about it at this link here. Scroll down to the section creating a new project, and it is these commands that I will copy and modify to suit my needs. Note that the current version of Guix Hall is 0.31. This particular version does not recognize many different file types, including SQL and configuration files. So I will have to use a workaround. A more recent commit will recognize many more different types of files, but you would have to package that yourself to use in Guix, or use it outside of Guix using configure, make, install. To keep things simple, I'll use what the Guix package manager provides me, which is 0.31. What I am interested in getting from HAL is the directory structure and the make infrastructure. The directory structure of the project I will slightly modify, because ultimately when I use my module, I would like to use modules lab solutions LNPG, LIMS Nucleus Postgres install. So I will have to include this directory in the directory structure. The make infrastructure involves loading all of the files that are necessary to use new make. So here are the commands that I pulled off the website, modified for my own use. So I'll start with the initialization command at a terminal. At a command prompt, I'll type in the HAL initialization command, and that creates my directory. I can look in and see the multiple SCM files that have been created. Guix is the packaging recipe, HAL is configuration file for Guile HAL, and Lab Solutions is currently empty. I want to use modules Lab Solutions LNPG, so I need to create the lnpg.scm file. Now if I back out and look at the directory tree, you can see I have an additional empty file, lnpg.scm. Let's take a look at these files. This is the Guix SCM. This is the packaging recipe created by HAL. Note that it has a placeholder for arguments. I will have to fill that in. It's also expecting an archive file, Lab Solutions 0.1. This is the HAL configuration file. This is currently missing all of my SQL and configuration files, so I will have to work around that. lnpg.scm was initially empty. This is the code that I have to add. Note that it exports a single method initdb. If we look at initdb, it essentially collects the arguments passed by the command line. These arguments are individually pulled out. This gives me information I need, like connection string parameters, whether the database will be local or remote, whether to initialize the database from the very beginning or just refresh with new data. One other point to make in this file is that you'll see numerous uses of lnpg store directory. This is the path into the store to find all my scripts. At this point, I don't know what that is. That'll be determined on the fly during the packaging process. At the beginning of this file, I have defined the store directory as some random characters, letters A through H. During the packaging process, Guix provides a sed-like function that will allow me to come in and replace this text with the hash, which is the path in the store, the directory path to all of my files. And then the other file that was initially empty is the labsolutions.scm. So this is a simple file. It utilizes the LNPG module, and essentially it is present to collect command line arguments. These will be passed to the initdb method in LNPG. So I will run this at a terminal, type in all of my connection string parameters and information needed to create the database, and that'll be passed in to initdb. I didn't speak in detail about most of the code in lnpg.scm. It is scheme code that implements all of the functionality in my bash script that it was involved with PostgreSQL setup and loading. Now back to Hall. Hall scan will find all of the files in my project and properly configure the hall.scm. Dist will load all the new make files that are necessary. I'll set up an environment and then auto configure and make. At this point, I am done with Guix Hall. I still need to add my scripts to the script directory, and I need to manually modify make.am with this code. Hall would do that for me in future versions when it recognizes these various extensions. The last step is to make the archive. So the files involved with the build system have now been added to the project. Let's create an environment. And let's look and see. So our make files have been added to the project, but you can see the scripts directory is still empty. So my next step is to add my scripts to the script directory and modify the make am file. Here is make am, and you can see that the sources were filled in by Guix Hall. Down in the extra dist, I had to add these lines, which will ensure that my scripts are loaded into the archive. I also need to modify the packaging recipe, Guix.scm. It's a good idea to read about the build utilities in the Guix manual. I'll be using utilities from Guix Build Utils, which is in scope during the packaging process. It's also good to know the various steps of whatever build system you're working with so that you can make modifications before or after a particular step. I showed you previously the arguments placeholder in Guix.scm, the packaging recipe. This is the code that I need to add to package my scripts. First, I say tests false because there are no tests. Next, I want to modify some of the phases. So after the unpack phase, I want to patch the prefix to all of my files. So this is where I extract the store path. So there is a structure provided that provides me with the outputs, and one of the elements of the outputs is the element out, which is the store path. So I can prepend any of the files in the store with the full hashed prepath. Here I'm using a function substitute asterisk. This is a Guix build utility. It is essentially the functionality of sed, the stream editor. So I can go into my existing file, lnpg.scm, look for the text A through H, and replace it with the full path that utilizes the hash of my archive. This is being done during the packaging process. I also need to make a directory and populate it with all of my scripts. So I'm making this directory in the store. So again, I need the outputs, which provides me with the out element, which will be the full path into the store. So I want to create my script directory, and it is a concatenation of that out element with the subdirectory scripts. That's where all my scripts will end up. And then a utility, make directory P, allows me to create that directory in the store. And then a second utility, copy recursively, allows me to copy all of the scripts in my archive to that store directory. Note that add before, add after, the first element is a phase. So this is one of the new make phases. This is not random text. You need to look up in the Guix manual the various phases of whatever make system you are working with and get the name right. The second element can be anything you want, is random text. I decided to call this make dir because it is descriptive of this activity. Here is my Guix SCM with the arguments modified. So I've done some preparation on Amazon Web Services setting up a Debian 10 instance. I have to install some software necessary for Guix to run, as well as the PostgreSQL client, but not the server. I will make the server software a dependency upon my package. I install Guix using the script available at Savannah, and I also installed the UTF-8 locales. Then I transferred my archive, which we just created, as well as the packaging recipe, guix.scm. So here we are on Amazon Web Services. This is a Debian instance that I have prepared. We can look and see what is installed in the store, Guile and UTF-8 locales. And then in my home directory, I have the recipe file, a bash script that'll run the program once it's installed, and the archive. So let's install from file using the recipe file. So dependencies will be installed. Note that I have not done a Guix pull. This is 1 gig T2 micro on Amazon, and it will run out of memory. If I don't do a Guix pull, I get older versions of software like Guile 3.02. Postgres is one of my dependencies from my recipe file. So Though I have older versions of software, that's okay. I'm just interested in having something that runs. How long this takes depends on how many packages need to be built locally. Should only take a minute if I'm downloading substitutes. Okay, so it looks like it has completed. We can look in the store now and see what's in there. And so you can see that my configuration scripts are in, the SQL scripts have been added, and I'm interested in this Lab Solutions SCM. This is the file that will load the modules Lab Solutions LNPG, and this LNPG file contains all the code that does the work. We can look now and see what is installed, and we can see that Lab Solutions is in the store. We can look now at this install script to see what it does. It utilizes Guix to run the labsolutions.scm, passing it all the command line parameters. Note that I'm specifying the complete path nn1yg. I get that right here from list installed will show me where my files are installed. So now I can run that script passing the parameters, the IP address, port, username, password, database name. Init means I want to initialize a new database as opposed to refresh an existing database. And local means it is local with respect to this Debian instant. The other option is remote if I'm installing on a remote cloud service. So let's run this. And so you can see it is running. It's setting up, my plate set table, assay run table, project table, etc. So now I can go in and take a look at the database. So I've logged in to the database LNDB. I can see that all of my tables are in there. I can run a query. So in the project table I should have 10 projects, and I see that yes, all 10 are in there. So in summary, I prepared a Debian instance installing some programs that are required by Guix. Note that I used apt-get to install PostgreSQL client. The server I defined as a dependency of my package in the recipe file, but PostgreSQL client is not yet packaged for Guix, so I can not define that as a dependency. My ultimate goal is a single command to install LIMS Nucleus and all of its dependencies. For that to work, all the dependencies need to be a Guix package. So we aren't quite there yet. The next step is to package the client and but right now we are one step closer. If you have questions as to the suitability of LIMS Nucleus for your process, contact us at info@labsolutions.com.